Alright, let's look at the homework 10.4, problem number 5. Alright, so we want to find the area of the region that lies inside the first curve, but the outside of the second curve. Alright, so let's do that. Alright, first I'm going to try to draw this picture using GeoGebra. Alright, so first one, I'm going to call it R1. So R1 of x is equal to 11 times cosine of x, and hit enter. Alright, so we got that, and we don't need to see that, so I'm going to just hide that. Then R2 of x is going to be equal to 5 plus cosine of x. Right? Then hit enter. Right, we got the R2, which looks like that. Right, then let's see, first curve is going to be curve. Then we just put R1 of t times cosine of t times R2 of t times sine of t. Alright, then parameter is t, and it's going to go from 0 to, let's say, 2 pi or something like that. Then here. Alright, so this is what it looks. Let's see, did I mess this up? Alright, let me double check. That looks kind of weird. Alright, so we have let's see, so here I think I messed it up. Oh yeah, because I put R2 and R1 and R1 mixed it up. Alright, so this is the picture. Alright, so more like it. Alright, then I'm gonna do the second curve. So curve. Then first one is, now that we're gonna use R2 of t cosine of t, then R2 of t sine of t, and 0 to 2 pi. Right, so we have that. Right, so we have a couple circles, looks like, and then we want to find the region between those two guys. So inside the first curve and outside the second curve. So I'm going to just grab this picture and then shade the region that we're looking for. All right, let's do that. All right, so let's see, it's going to be inside the first curve and outside the second curve. So we're talking about our region right here. All right, so I'm going to just shade this region. All right, so this is what we're looking for. Alright, so we need to find the point, let's see, here. That's probably the beginning point, and that's probably the ending point. Then we just need to find the angle here. So from the origin to the starting point, and this origin to the ending point. Right? So we need to know the angle here. Right? So that's going to be our A, and then angle there, that's going to be our B. Alright, so you can see that these two red dots are just the intersection between these two circles, so we can just set them equal to each other. So we're going to have, so 11 cosine of theta is equal to 5 plus cosine of theta. Alright, then we can just subtract cosine of theta, which is going to be 10 cosine of theta equals 5. Then we can divide through by 10 to get cosine of theta is equal to 1/2. Right, so this will give us angle theta. Right, cosine is equal to 1/2 when angle is let's see, 60 degrees, so pi over 3, and it's going to be also negative pi over 3, so it's going to be plus or minus pi over 3. And you can add any multiple of 2 pi, but this will probably do it. So in this case here, A is going to be negative pi over 3, and B is going to be positive pi over 3. Alright, so let's set up the integral here. So we want to find, so area A is going to be, alright, so we have, we need to find the R1, so I'm going to call this R1. This is going to be R2, alright. So we need to do a 1/2, alright, integral, right, from negative pi over 3 to positive pi over 3, right? Then we just have to do R1 squared minus R2 squared, and with respect to theta. Alright, so let's find the expression for R1 squared and minus R2 squared. So let's do it on the side. So R1 squared minus R2 squared is equal to, if you square that, you have 11 squared, so it's going to be 121, and then you have a cosine squared of theta, right, minus, right, and R2 squared, so it's going to be 5 squared, so it's a 25, and plus, and 2 times 5 is cosine, so 10 cosine of theta, and plus, and cosine squared, so cosine squared of theta. Alright, so if you combine that, then you're going to get, let's see, we have 221 cosine squared, and we have a cosine squared there. It's actually a subtraction. So you have 120 cosine squared of theta. Then we have a minus 10 cosine of theta. So that will take care of this guy. And then you have a minus 25. So that's just a number. So minus 25. Alright, then since we need to find the antiderivative, I'm going to replace cosine squared by, so it's 120 times 1/2 and 1 plus cosine of 2 theta, right? And a minus 10 cosine of theta minus 25, right? So we can cancel 2 and 120, so that would be 60, right? So what you're going to get is, let's see, you have, right, 60 here times 1 and a minus 25. So that's going to give us 35. So 35 is just going to be a constant. All right, then you're going to have plus 60 times cosine square, cosine of 2 theta, cosine of 2 theta, and a minus 10 times cosine of theta. Alright, so we have the integrand kind of simplified out. So we're going to have, alright, so you have a 1/2, right, integral, alright, from negative pi over 3 and positive pi over 3. And then you have a 35 plus 60 cosine of 2 theta, and a minus 10 cosine of theta, d theta. Right? Let's simplify this a little further. Since all three terms are even functions, we can actually do the half of it and multiply by 2, because you can see that the upper half and the bottom half exactly the same shape. So I'm going to go from 0 to pi over 3. So I'll just do a half of it, then multiply by 2. So cancel that. All right. So multiply by 2, and just to take the half of the region. All right. So this is going to be equal to, right, antiderivative of 35 would be 35 theta, right, plus 60 times antiderivative cosine is sine of 2 theta, and then you have to divide by 2, right, minus 10, and antiderivative is sine of theta, right. Then we're going from 0 to pi over 3. Alright, so plug it in. Alright, so we're going to put 35 and pi over 2. So 35 pi over, 3. Right? Then here, if you cancel 2 and 60, so that's 30. So you're going to get the 30 times, if you plug in sine of 2 pi over 3, so that's going to be what, square root of 3 over 2, right, minus, 10 times, sine of pi over 3 is again square root of 3 over 2, right, minus, if you plug in 0, it's all 0, so that's it, right. So you're going to get 35 pi over 3 and plus, so this is going to be 30 minus 10, so it's a 20, divided by 2, so it's going to be 10 square root of 3. Right? So this is the area of the shaded region. Right? So let's type it in. Alright, so what we got was 35 pi over 3 plus 10 square root of 3. Alright, so submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.